Hello and welcome to this fourth session in the series Excel for Finance. In this session, we will be talking about nominal rate and effective rate. In the last session, we saw that the NPER function in Excel represents number of periods and not always the number of years. Why is that so? The reason is, all along we have assumed that compounding or discounting is done once in a year. But in reality, in many cases, compounding is done more frequently or more than once during a year. Let us take an example where a deposit scheme offers 8% interest per annum, which is compounded semi-annually. That means now the frequency of compounding is twice in a year, that is every 6 months. When the firm is paying 8% interest for 1 year, obviously for a 6 months period, the interest paid will be 4%. So let us take an example here. Assume that I have invested 1,000 rupees today. At the end of 6 months from now, I will get 4% interest on that, and the value of my deposit will become 1,040. Now, for the second 6 months period, this is more interesting. I'm not going to get 4% interest on my original investment of 1,000 alone. I'm going to get 4% interest on this 1,000 plus the interest I received during the first 6 months period. So 1,040 will now be compounded at 4% rate. And at the end of 1 year, I will get 1,081.60. In the above example, if the compounding was done only once a year, the value at the end of 1 year would have been rupees 1,080. But due to semi-annual compounding, the value is slightly more, which is 1,081.60. So here, even though the deposit offered 8% interest, because of semi-annual compounding, what we got is not 8%, but 8.16%. The rate offered by the institution, that is 8%, is known as nominal rate, and the actual rate of return that we got, which is 8.16%, is known as the effective rate. Usually, financial institutions and banks quote nominal rate, but what we get will be different. Now, how do we compute the effective rate, which is RE, when the nominal rate, which is RN, is available? The formula is very simple. 1 plus RE will be equal to 1 plus Rn divided by M to the power of M, or RE will be 1 plus Rn divided by M to the power of M minus 1. What is M here? M represents the number of times compounding is done in a year. So in case of semi-annual compounding, M will be 2. For quarterly compounding, M will be 4. And for monthly compounding, M will be 12. Now let us take a real example. Most of the banks in India use quarterly compounding for computing the maturity value of fixed deposits. I have taken an example of HDFC Bank here, and I have circled this 1 year rate. So if you make a fixed deposit in HDFC Bank today, the rate of return they offer you, or the rate of interest they offer you, is 6.6%. But this 6.6% is a nominal rate. You will actually get slightly more than this. So how much is that effective rate is what we are going to calculate. Now, we don't have to use any formula. We can straight away go to Excel and see how nominal rate can be calculated using Excel. Let us do that. Okay, so I have an Excel sheet here where I have used the same nominal rate, 6.6% per annum offered by HDFC Bank on a deposit of 1 year maturity. Frequency of compounding is quarterly, or number of compounding periods per year is 4, because since quarterly compounding is done, you are going to compound it 4 times a year. So 6.6 will be divided into 4 compoundings by 6.6 divided by 4. Now, how do you get the effective rate? There's a function in Excel for effective rate, which is effect, bracket open, nominal rate, comma, NPERY, which is number of periods per annum per year. Let us do that formula. I'm going to show you. Is equal to effect, bracket open. It will ask me for nominal rate. I'll just click on the nominal rate, comma, NPERY is number of periods in a year. Number of periods in a year is 4. I just close the bracket and press enter. I can convert this into percentage, and I can see that the bank is offering 6.6% nominal rate, but I will end up getting 6.77% in reality because compounding is done 4 times a year. Similarly, if I know the effective rate, Excel also helps me to work backwards and get the nominal rate. Let me take the same thing here. Let me put 6.77% here as my effective rate. I'm keeping the compounding frequency as 4. Now, how do I get my nominal rate? I'm working backwards now. The formula is nominal, bracket open, effective rate, comma, number of periods in a year. Let's see how to do that. Is equal to nominal, bracket open, effective rate, comma, number of periods in a year, 4, bracket close, enter. See, I get 6.6%. So these two important formula there, two important functions are there in Excel, which will allow us to calculate effective rate when we know the nominal rate, or calculate the nominal rate when effective rate is known to us. Okay, so we have seen these two functions: effect, nominal rate, comma, number of periods in a year, nominal, effective rate, comma, number of periods in a year. This is very important because the quotations given by banks and financial institutions when we are trying to deposit our money is actually nominal rate. Our effective rate will be based on the number of times compounding is done by the bank or financial institution. Now, obviously, the next question is, when compounding or discounting is done more than once a year, how do we calculate the future value and present value of cash flows? That is something we shall see in the next session. I hope you enjoyed learning finance through Excel in this session. Thank you very much for watching.